Hello, Course 3 students, and welcome to our 7th lesson in Chapter 4, which is all on real numbers. So today we are going to be talking about looking at different types of numbers and classifying them based on those types of numbers they are. So we have been, ever since, whenever you started, learning about numbers, for the most part, we've always been talking about real numbers. And it's just a matter of what kind of real numbers are they? Are we considering them rational, irrational, integers, whole numbers, natural numbers? And so we'll talk a little bit more about that system as we go through. So our objective today is I can learn to determine if a number is rational or irrational. So we're going to talk about mainly the big difference is rational and irrational. And then when we get into rational, there will be some more steps into helping identify these numbers. So here's kind of the big key idea. It says you already know that some numbers can be classified as natural numbers, whole numbers, integers, and rational numbers. I've talked a lot about integers this year. We've talked about our integer rules with adding and subtracting negative or positive numbers. We've talked about rational numbers as well when we were talking about our decimals and our fractions. Remember, rational numbers are anything that can be written in the form of a fraction, which also means decimals usually can be written in the form of a fraction. It says recall that rational numbers can be written as a fraction or as a decimal that either terminates or repeats. So it's okay if they're repeating decimals or it's a decimal that stops is basically what they're saying to this. Here is, though, irrational numbers. We haven't really talked about these, so I would suggest this might be a good thing to write down or write down a few examples of them. You don't necessarily have to write word for word, but write a few key ideas. So irrational numbers can only be written as decimals that do not terminate or repeat. So meaning they're decimals that never end, or they're decimals that do not repeat. So they don't have a pattern to them. If a whole number is not a perfect square, then its square root is an irrational number. Oh, so we were just talking in the lesson on Friday about non-perfect squares, and so like square root of 2, when you get a decimal and you plug it in a calculator, that's going to be considered an irrational number here. So that's why they're showing things like, oh, the square root of 2, the square root of 17, I don't know those, square root of 11, because they're going to give you a decimal answer. The set of real numbers consists of the set of rational numbers and irrational numbers. So all the numbers we've been working with up until this point in math have been real numbers, as I said. We're either working with rational or irrational. So here's how they break it up in this little diagram, and it's a little blurry on this one, but I have it on the other slides for you to see a little bit better. But they break it down into two parts. You've got rational, you've got irrational. Within the rational, there is different categories. There's things like integers, whole numbers, natural numbers. So sometimes our numbers can fit into multiple parts of this category on this side. On this side, it's just irrational. If it's irrational, it's irrational. So let's take a look at our first example. And I gave us the little graph here because it says, write all names that apply to each number. So we are going to use this little table here, or organization or graphic, I guess, to help us determine this. And more than likely, I will also give this to you here on the test to help you. So we have the square root of 3. Now, they talked about how square roots have to be perfect squares. Well, I know the square root of 1 is a perfect square because you get 1. And I know that the square root of 4 is a perfect square because you get 2. But the square root of 3? It's somewhere in between 1 and 2, but it's going to be some weird decimal. And they told me that if it's not a perfect square, it's going to be irrational. So in this case, the square root of 3 is irrational. And that's the only name you can put down, because if it's irrational, there's no other label to it. It gets more tricky if you go into rational numbers. So your next one is negative 52.28. Ooh. I've got a negative, which I would think is probably an integer, but it has decimals. Usually integers we think of as a whole value, either positive or negative. And so if I'm looking on this side, it is a decimal that terminates or ends, so it's not going to be an irrational number. So it would be rational. But it's not quite an integer because it's got decimals. But it's not quite a whole number either because it's not above 0. So this is all it is. It's just rational. So sometimes we might run into more, but this one's, they're just irrational and rational. So the next part says then the square root of a negative number is not a real number. Oh, hey, we talked about the set of all real numbers. They're telling me if I took the square root of maybe like -5, it's not a real number? What? So as you get a little older in math here, and we're not necessarily going to completely cover it here, there's a thing called imaginary numbers. So if you thought math was complicated now we can be like, oh, there's an imaginary number. And usually it's written with a little italicized I. But we're not going to dive too far into that. But they're just saying that the square root of a negative number is not a real number. So I can't classify it's not a real number. A fraction with a denominator of 0 is undefined because you cannot divide by a 0. Remember, the fundamentals of dividing is that you're dividing into different groups. So if you had 5 cookies and you divide it by 0, nobody, you can't do that. Even if I had these 5 cookies, I'd have to still divide them by myself, so I'd at least have to divide by 1. So dividing by 0 also does not work. So it is not a number at all. It's just not even a number. A lot of times we call it, like they said, undefined is what we would say if you divide by 0. So let's take a look at the next set they have. It says, state if each number is rational, irrational, or not a real number. So this time they don't tell me that I have to give every single name for these numbers. I just need to decide one of the 3. Is it rational? Is it irrational? Or is it not a real number? So let's go ahead and look at the first one. I have a square root of 15. Square roots, as long as it's a value here that's a positive, are a real number. Then I just have to think, is it a perfect square or not a perfect square? Well, I don't know any 2 numbers that are the same that when multiplied could give me an easy number. So whole numbers is what I mean. I don't know any 2 whole numbers that when multiplied together that are the same number that could be 15. So that's meaning it's not a rational number, but instead it should be an irrational number. So this one actually is written as 3 out of 0 or 3 divided by 0. It's just hard to type. Hey, we just talked about it in this one. A fraction with a denominator of 0 is undefined because you cannot divide by a 0. So it's not even a number at all. So for this one, is it rational, irrational, or not a real number? Well, rational and irrational are real numbers. So in this case, I'd say not a real number. I'm just going to abbreviate number as the hashtag because that means number too. All right, so this next one, I would also rewrite this a little bit, is 1 out of 9. So it's a fraction within your square root bar, okay? So I'm taking the square root of 1/9. Well, it's not a perfect square. This is a good question on this one. I wonder how the book defined this, because if you're looking at this, it's not a perfect square, but there's also a rule that you can take both the top and the bottom and take the square root of it. So you could get, oh, the square root of 1 is 1 and the square root of 9 is 3. So that means it would be rational. So I'm a little confused on this one too. I'm just going to double check that I am thinking about it the correct way with the book here. Yes, so they did the same thing that I just did. They broke it down so you can take the square root of the top and the square root of the bottom instead of taking the square root of the whole 1/9. And it would give you then 1/3, which is a rational number. Oh, now we have the square root of -13. Well, we talked a lot about that. If you have a square root of a negative number, it's not a real number. It's called an imaginary number. So we would say, not a real number. It's not real. It doesn't exist. I wonder what your calculator does if you plug that in. Oh, yeah. So if you actually, in the graphing calculator at least, it comes up with an error code and it says non-real answers. I wonder what it does in this one. This one just says domain error, meaning it also doesn't work. So let's go on to one more problem I think we have. So this one's talking about a property we're not necessarily always going to be talking about. I know, understanding properties are important, but not necessarily do I think that they're super important to know the name all the time. But it does say that any real number can be shown on a number line. The density property of real numbers states that between any two real number is another real number. This property is not true for whole numbers or integers. For instance, there is no integer between -2 and -3. So it means that you can't have another whole value in between those. There can be another real number with a decimal form, but it's not going to be another whole value all of a sudden. So what we need to do for this one is find a real number between 1 and 1/3 and 1 and 2/3. So it says that there are many solutions in between these two numbers. One solution is halfway between the two numbers. So to find it, add the numbers and divide. So they already give me the hint on how to solve this one. So right in between these two numbers, so if I created a number line and maybe I said this is 1, this is 2, I have 1 and 1/3 here, 1 and 2/3 here, 1, oh, actually 1 and, this would be 2. Let's just say that. So we got to find what would be in the middle here. And so they say add the two together. So I'm going to take 1 and 1/3 plus 1 and 2/3. Well, 1 plus 1 is 2, but 1/3 plus 2/3 is 3/3, which is another whole. So I would have 3 whole values. So the second part then they say, we added the numbers and now we're going to divide it by 2. So 3 divided by 2, well, you could think of it as 3/2 still, but if I broke it down into 2 pieces, that would be 1.5. Or, again, you could say it as 1 and 1/2. And that would be my solution. That would be a number that's in between 1 and 2, or 1 and 1/3 and 1 and 2/3. Alright, so we will keep practicing how to classify our numbers here in class. And then just let me know if you've got any questions.